Hello there, and welcome to Geometry, Lesson 10.3, Area of Regular Polygons. All right, so things have gradually been getting more difficult. We learn about the word regular again today, and can anybody remember what the word regular represents? In geometry, regular means, correct, all sides and angles are congruent, okay? So regular polygons is what we're going to find areas for, and this is an important piece of information because all the interior angles will be the same, as well as all the side lengths will be the same. All right, so there's a couple pieces that we need to understand, a couple vocab words, and I'm going to draw a regular triangle. All right, and I'm going to let you know that there are some pieces to regular figures that changes. There's a piece that goes from the center of a shape to a side, forms a right angle. This is called the apothem. You know, not opossum, but apothem. Or some people call it apotheum. Okay? It is very similar to an altitude. Okay? Notice, they both form right angles. The difference is an altitude starts at a corner and apothem starts in the middle. But they both form right angles. Okay? The next line segment we're going to talk about is one that starts and goes to the corner. Okay? That line segment is known as a radius. Now, the reason why it's known as a radius is because in a circle, remember when we circumscribed a circle around the shape, and I'll put the triangle inside of it. So when I have the triangle inside of it, notice when I draw that line segment, it's also the radius to the circle, which would be the same reason why it's called the radius here. Is because when you have any regular shape, you can always circumscribe a circle around it, and this line segment would be the same in both. The circle would touch here, the radius would also touch here, meaning that the name is the same, and it is actually the same exact line. The difference is you don't see the circle. Okay? So we've talked about the apothem, the radius, and then of course that point there is called the center. All right, so let's go back and review some of the material we're going to need to be able to be successful in finding angle measurements in a regular shape. One of them is this formula, 180 times n minus 2 divided by n. This will give us our angle inside of a regular figure. Now, why is that important? Well, if you notice, the apothem makes a right angle, and this radius would complete a right triangle. Thus, if we know what the angle is here, we'll know what half of it is because the radius bisects the angles. Okay, and that's an interesting thing to know so that when you're doing the work, you know what is being bisected, what is a regular. Hang on, let me move things around here a little bit. All right, so let's just look at one regular shape. We'll look at a pentagon. Now this is my best attempt at a regular pentagon. Okay, and we're supposed to know what all of those interior angles would be. So it's five-sided, so it'd be 180. Okay, and I put it into that formula, and I have five-sided shape should have how many degrees? Correct, you should know it's 540. and then you divide it by 5, which should give you, correct, 108 degrees. So that means each one of these angles here, each one of the interior angles would be 108 degrees. Well, now let's take a radius, and we draw the radius. That radius would bisect that angle, okay? Thus making that angle how much? Correct, 54 degrees. 54 degrees here and 54 degrees here. Now, why would we need to do this? Well, sometimes they give us all the things we need for our formulas, but you and I both know that most of the time they don't. So let's say we needed the apothem, which would be this measurement right here. Okay? Well, now we have an angle measurement, and if we had a side measurement, we would have enough information for us to use our sine, cosine, and tangent ratios. Okay, so this is where everything comes together. Now, do you have to remember sine, cosine, tangent? No, you'll have it on the reference sheet. Do you need to remember this formula? No, you'll have it on the reference sheet. But you do have to understand what this is and how you get it. All right, so understanding those angle measurements, please understand that the radius bisects your angles. The apothem also bisects the sides. So that means all of these side lengths are always cut into 2 equal pieces, okay? So these are all important pieces of information of what happens. Understanding that the altitude is a segment bisector, or excuse me, the apothem, and the radius is an angle bisector. The radius will always bisect the angles, okay? These are properties that you need to keep in mind when doing any of this work. Now, what happens if I want to find the interior angle here? Okay, now this one's unique as well, because if you look at the shape, you'll see that it's divided into 5 isosceles triangles, right? And if I know this is 54, then I also know this is 54. And what do I know about a triangle? They will always add up to equal 180, correct. Now, is there another way of finding this measurement? Of course, you can do 360 divided by 5 triangles, and you're going to find what this measurement is. So there are a lot of different ways of finding the angle measurements. You just need to make sure that you pick one that works for you and that you use it all the time. Okay, so there are going to be different problems where they give you different pieces for you to find. Your job is to make sure you use the right pieces. All right, so let's look at some problems. Let's see if I were to look at got it problem number 1. Okay, we'll look at got it problem number 1. And you would see that at the right of an octagon. So now we're talking about an octagon. So that means it has how many sides? Correct. You try to do the problem and then pause the video. And when you come back, we'll work on the answer. All right, so now we're back. Hopefully you know an octagon has 8 sides. So I'm going to draw a generic octagon real quick. Okay, it's like a stop sign. And it says, what would the angle measurements be? So here's an octagon, and I know that it's got radiuses that do that, right? And then, of course, the apothem, I'll use a different color, is the one that forms the right angle here. The apothem is a bisector, Those radiuses are bisectors. Okay, so these are all isosceles triangles. So that means this piece is equal to this piece is equal to this piece. These angles are bisected. So let's find some measurements. So we'll do 180 times 8 minus 2 over 8. And that would find us this angle right here. But in essence, it actually finds every single angle. Why? Because all the angles are correct, the same measurement. All right, so hopefully you have gotten your calculator and you've already figured out 180 times 6 divided by 8 gives you an angle measurement of 135 degrees, which means this angle here is 135 degrees. All right? If I bisect it, that gives me 67.5, which means I'm going to redraw this triangle now. This angle here is 67.5. And this angle is also 67.5. Now, what is this angle up top? Right here. Well, if you took 360 and divided it by 8, you would get 45 degrees. If you add 67.5 plus 67.5, you get 180 degrees. So again, there are many, many different ways for you to find the measurements inside of here. You could take the number of sides, because you'd have 8 different triangles, and find the center. Then use your isosceles triangle work to figure out the 2 other angles, because it would be 180 minus that divided by 2. Okay, so a lot of this work you've done. Okay, now they're just expecting you to remember how to do it. Now, those measurements are going to be important later on when we're trying to find apothem pieces. You know, we can use a squared plus b squared equals c squared. The easiest problems are going to be the area problems where they give us all the information. Okay, so let's get into what the area formula is for a regular polygon. Area is equal to 1/2 the perimeter times the apothem. Okay. Area equals 1/2 the perimeter times the apothem. Now, when does this become easy? Well, let's say you have the area of, and I'll just pick a shape, a decagon. Okay, so a decagon has how many sides? Everybody should know it has 10, correct? So let's say we have a decagon, and they're actually going to give you the length of one side. They give you the length of 8 inches. Okay, so they say the decagon has a side of 8 inches, and they tell you it has an apothem of 12.3 inches. Okay, so in this problem, they've given you all the information. You don't have to do any right triangle work. Why? Because they gave you the length of one side, so you can find perimeter. Hopefully we remember perimeter is where you add up all the sides, right? So that means we'd have 10 sides of 8, which means our perimeter is equal to 80. Well, we have our apothem. They've already given it to us. So now this is just plug and chug. Area equals 1/2 80 times 12.3. It's all calculator work now. All right, so you plug it in your calculator, and what do you get? Hopefully you know you get 492, correct. 492 what though? Inches squared. All right. Okay, got it problem number 2. And then come back, pause your video, and then come back to see if you have the right answer. The got it answer was 232 centimeters squared. All right. Good job. Hopefully you did it well. All right, now we get into the hard stuff. Using our special right triangle work or Pythagorean theorem work or sine, cosine, and tangent work. Okay, the first step would be finding the pieces you need. So let's say we have a 6-sided shape. In that 6-sided shape, we should automatically know what this angle is going to be. Right, this angle up here is going to be 60. Why? Because in a 6-sided shape, you have 6 triangles. Okay, so that means this measurement here is going to be 60 degrees. And if I drew another triangle, it would be 60 and 60 and 60 and 60, because when we draw a circle around it, it would be 360. Correct. When I draw an apothem, it would be how much? Well, notice that apothem bisects this 60 degree. So now I have a 30, 60, 90 degree triangle. Yep, we start doing 30, 60, 90 work. Okay, do you have to memorize these formulas? No, they're given to you on the test. Okay, they're on the reference sheet. But I need the apothem. Now they're going to tell me that the side length of this is 3. Now finding the perimeter is going to be easy. So I start by writing area equals 1/2 perimeter times the apothem. Perimeter is going to be no problem at all. Why? Because there's 3 millimeters for this side, and there's 6 sides. So that's 6 times 3, which is 18. So I have the perimeter of 18. I am missing the apothem. Now remember, there's 2 ways of doing the formula. You can do 1/2 perimeter times apothem, or you can do perimeter times apothem divided by 2. They're the same. So I just write them that way. And I'm missing the apothem. So now I'm doing this work to find the apothem. Now, notice they put the 3 over there, but they could have put the 3 anywhere. Why? Because they said this was a regular shape. What does the apothem do? Hopefully you remember, it bisects. So that means this piece is 1.5. So I go down here on my special right triangle and I put 1.5. Now, if I needed to find the radius, that would be easy because I'd multiply by 2, right? This is our special right triangle, so this side is multiplied by 2, this side is multiplied by the square root of 3. Now, the only thing they do to make this work really difficult is they'll change the orientation. Your job is to kind of spin your paper around and put it back the normal way. So if I want to know the radius, which is this line, I would multiply by 2, and this would be 3. Now, do I need the radius? No, I need the apothem. So to find the apothem, I'd go up this way, and it's 1.5 times the square root of 3. Okay? So now I have the apothem. I've done my special right triangle work to find my apothem. And I just take this apothem, plug it into the problem. So it becomes 18 times 1.5 square root of 3 divided by 2. Okay? So I put it in my calculator, and you should get, correct, an approximate answer. You're going to get an answer that's 15.3826859, right? So if we round this, it would be approximately 23 millimeters squared. Okay. Notice, Regular shape, draw it, know my bisecting things, put my marks. Okay. Now, will that always happen in a hexagon? You're right. In a hexagon, only in a hexagon, will the side length and the radius be exactly the same. That only happens in a regular hexagon. Okay. All right, got it problem number 3. Pause it. Come back and check your answer. All right, so in your got it number 3, the perimeter should have been easy. That would have been 16 times 6, right? So the perimeter was what? 96. So you have area equals 1/2 perimeter times hypothesis. And you have the perimeter, so area equals 1/2 96. And I'm missing that number right there. So I go over here and I know I'm doing right triangle work. And it's exactly like my other hexagon, so it makes it easy. I know that when I draw my other hexagon, it was a 30, 60, 90. And what do I know about the measurement here? Correct, it was bisected, which means this measurement is 8. And this would be multiplied by the square root of 3, this multiplied by 2. And my apothem is this piece. So it's 8 square root of 3. So I just come over here, 8 square root of 3. Plug it into my calculator, and what do you get? Well, let's see. We've got 96 times 8 square root of 3 over 2 equals 665, right? Approximately 665 feet squared. Okay, so for a lot of these regular figures, you're going to have the formula work, and then you're going to have some sort of right triangle work. All right? Okay, well, you do the check your understanding, and then good luck on the homework when we're in class.